Semester review number 36, determine whether the mean value theorem applies to f of x on the interval from 2 to 3. If the mean value theorem can be applied, find all values of c in the interval. If the mean value theorem does not apply, state why. So mean value theorem has to meet two criteria. It has to be continuous, the function has to be continuous, and it has to be differentiable for all interior points. So between 2 and 3, not including 2 and 3, but it has to be differentiable for all points between 2 and 3. Well, the f of x is it's a polynomial, so all polynomials are differentiable and continuous. So we're good. So we know that it's going to meet the criteria for the mean value theorem. So because we know the mean value theorem applies, we know that there has to be some c in the interval where the instantaneous rate of change is equal to the average rate of change. So we're going to find the average rate of change, which is just f of 3 minus f of 2 over 3 minus 2, because this is A and that's B. So f of 3, 9 minus 9 is 0 minus f of 2, so f of 2 is 6 minus 4, which is 2, so we get negative 2. Okay, so going from the point 2 comma 2 to the point 3 comma 0, it has a slope of negative 2, just to show you that. So we're going from the point 2 comma 2, plug in 2 in, I get 2, plug in 3 in, I get 0. The average rate of change is negative 2. It has a slope between those 2 points of negative 2. So there has to be somewhere in that interval where the curve has that slope also of negative 2. So we have to find the derivative, the instantaneous derivative, and that would be 3 minus 2x, and we're going to set our derivative equal to negative 2 and see when it happens. So 3 minus 2x equals negative 2. Negative 2x equals negative 5, so x equals 5 halves. Notice that 5 halves is in the interval, that's 2.5, so between 2 and 3, yeah, at 5 halves we have, well, it's a parabola that kind of looks like this. So at that point right there is when the instantaneous is equal to the average. So c equals 5 halves. That's the only point that we found in the interval that supports the mean value theorem.